G- Good day everyone. In this video is about finite difference method for ODE, and we solved some problems, and the question is formulate the finite difference method for the following ODE, and our equation is the second derivative of y with respect to x plus x times dy over dx plus y is equal to 2x squared. This is the linear boundary value problems, and we're going to solve with a boundary condition of y naught and y at 0.9 is equal to 1, and let's use delta x is equal to 0.1, and first we discretize the domain. Four, 5, 6, 7, 8, 9. From the start, 0, and we have 0.1, 0.2, 0.3, and 0.4 to 0.9. And they have 8 8 internal nodes, and they have 8 internal nodes, so there will be an 8 by 8 system, and this function is to have a second derivative of y with respect to x and first derivative of y with respect to x and y. So the result is going to look, here is the result, and finding in our finite difference approximation that will use and will need the second derivative approximation here, and the first derivative approximation using second order here, second order, and will be as a finite difference method. So we will plug those in for our first derivative will get yi plus 1 minus 2yi plus yi minus 1 all over delta x squared plus xi times yi plus 1 minus yi minus 1 all over 2 delta x plus yi is equal to 2xi squared. And this is now our algebraic equation for the y value and 8 internal nodes. And our solution, and we have simplify this algebraic equation, is going to multiply through by 2 here, 2 times 2 delta x squared, and we get the yi plus 1 minus 4yi plus 2yi minus 1 plus xi delta x times yi plus 1 and minus xi delta x yi minus 1 plus 2 delta x squared yi is equal to 4 delta x squared xi squared. So next we collect like terms, and for our first term is here and here. For the term of yi minus 1, the coefficient of 2 minus xi delta x plus, for the second coefficient is yi here and here. For yi, coefficient of negative 4 plus 2 delta x squared plus, for the third term here, third term, yi plus 1 and the coefficient of 2 plus x I delta x is equal to 4 delta x squared xi squared. And this is our general equation. General equation. And we write in a matrix form for all of our general equation, and we have this by resulting linear system with delta x is equal to 0.1. We have negative 3.98, and the same going all down in the diagonal, and that the negative 4, and this is the coefficient, second coefficient. So by substitute the delta x is equal to 0.1, and this is how we get negative 3.98, and the same for every equation at the middle here on the matrix. And but when you see the first coefficient and the third coefficient have xi, and xi are in terms of in the yi minus 1 coefficient, and the coefficient for yi plus 1. Going down the diagonal, and we have 2.0, 2.02, and 2.03, and so on. They basically those diagonal are increasing, and the other side of diagonal is decreasing, depend on their nodes, or depend on xi. To compute or to get this for first approximation or first coefficient is here y naught, and here is yn. y naught is equal to 2 minus xi delta x. For the value of x, for the value of xi is equal to 0.1, and for the delta x is equal to 0.1. We substitute this equal to 0.1 and 0.1. The answer is 1.99 because of in the table of matrix 1.99 is this location, and we use other xi is equals to 0.2, sorry, 2 0.2. The answer is 1.98 here. 1.98. Basically, in this x sub I is equal to 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8. The third coefficient is yn is equal to 2 plus xi delta x. We substitute the value of xi and delta x. And the answer is 2.01 here in the matrix. And for this, for the first and last value, and here for the last value on the right hand is going on have the right and side value here, but in minus for this is minus y naught, and this is minus y n. To get this value, we only substitute the xi and the value of delta x minus the first coefficient And for this value, uh, also this right hand side minus this coefficient. Oh, sorry. Mhm. Yeah. The answer is 1.9896.